Of course, you are familiar with the human eye. Perfect circles, just with different colors. But then you look at eye of a goat, you see it's horizontal rectangular. A cat? Its eyes are vertical slits. Cuttlefish with W-shaped pupils? How is that even possible? Turns out these shapes aren't random. Each one is a precise survival tool that reveals where the animal sits on the food chain and how it hunts. Almost every animal with horizontal pupils is prey. Deer, horses, goats, sheep, rabbits, cows. Survival depends on spotting danger early. Imagine a sheep lowering its head to graze. For those few seconds, it's extremely vulnerable. A predator could be 50 yards away in the brush. Round pupils like ours would shrink in bright sun and create huge blind spots on the sides, which would leave it completely defenseless. Nature's fix? Horizontal rectangular pupils. They pull in massive light from left and right, while blocking glare from above and below. This creates a panoramic widescreen view of the entire horizon. The animal scans for movement across a huge area without turning its head. But it gets smarter. When the head tilts down 90 degrees to eat, horizontal pupils would flip vertical and ruin everything. So nature added cyclovergence. The eyeballs physically rotate inside the sockets up to 50 degrees in opposite directions. Pupils stay perfectly parallel to the ground, no matter the head angle. How do you hunt an animal that sees nearly 360 degrees? You don't chase. You hide, stalk, and pounce. That's why foxes, domestic cats, vipers, crocodiles, and many snakes evolved vertical slit pupils. If horizontal eyes are for evasion, vertical slits are pure hunting weapons. Ambush predators live or die by perfect distance judgment. These slits use two optical tricks at once. The narrow horizontal width makes vertical edges razor sharp for excellent stereopsis, binocular depth perception. At the same time, the tall vertical shape creates shallow depth of field. Target stays crystal clear, while everything in front and behind turns heavily blurred. The brain measures that blur like a laser rangefinder and calculates exact distance without moving the head. This system turns them into silent, deadly assassins with insane precision. Big question: if vertical slits are so perfect for hunting, why don't lions, tigers, wolves, leopards, or cheetahs have them? Why do the largest meat-eaters and humans all have round pupils? The answer is height and style. Vertical slit advantages disappear when eyes are higher off the ground. A small cat hunting low gets huge benefits from the blur trick, but a lion at 3 feet tall, a wolf, or a human at 6 feet is already high enough for normal binocular vision to work fine. Large predators are usually pursuit hunters. They chase across open fields in daylight over long distances. They need clear, all-purpose, high-clarity vision. Nature defaults to reliable round pupils for tall apex hunters. Small nocturnal predators face the hardest challenge, need maximum night vision, but can't get blinded in daylight. The geckos solved it with one of the craziest pupil designs on Earth. At night, the pupil opens into a huge circle, swallowing every photon. Gecko eyes are up to 350 times more sensitive to light than human eyes. But if that giant pupil stayed open during the day, the bright sunlight would completely overwhelm and damage its retina. So it closes into a sharp vertical line with 4 distinct diamond-shaped pinholes. In bright light, these become 4 separate tiny apertures. Each pinhole projects its own image from a slightly different angle. When the gecko locks onto a target, all 4 images overlap into one ultra-sharp picture. But if the prey moves out of focus, the image splits into 4 blurry versions. This isn't a glitch, it's a feature. The gecko's brain measures the gap between those 4 blurry shapes to calculate exact distance with 0 head movement. It's a raw biological rangefinder. We can't talk about wild eyes without hitting the insects. Flies, bees, dragonflies, and most bugs have compound eyes. Thousands of tiny individual lenses called ommatidia packed together. A housefly has around 4,000 ommatidia per eye. A dragonfly can have up to 28,000. Each tiny lens captures its own piece of the world, creating a mosaic image. Resolution is low compared to our eyes, but the advantages are massive. Near 360-degree vision with almost no blind spots. Insane motion detection. Their brains process images so fast that the world appears in slow motion to them. A fly sees you swinging your hand in slow-mo and easily dodges. Many can also see ultraviolet light and polarized light that we can't. Bees use UV patterns on flowers as landing guides invisible to humans. Dragonflies, the top aerial predators, use their compound eyes to track prey with incredible accuracy, making them one of the most efficient hunters on the planet. Compound eyes trade sharp detail for speed and wide coverage, perfect for fast flying, quick reacting insects. But wait, Some animals took eye design to absolute extremes. The mantis shrimp has the most complex visual system on the planet. While humans have 3 color receptors, the mantis shrimp has between 12 and 16. It can see ultraviolet light, polarized light, and even circular polarized light that no other animal can detect. Its eyes move independently, and each eye has trinocular vision, meaning it can judge depth in 3 different ways at once. Basically, it sees a world full of colors and patterns we can't even imagine. Then there's the chameleon. Its eyes work like independent turrets. Each eye can rotate nearly 360 degrees separately, allowing the chameleon to look in 2 completely different directions at the same time. One eye can watch for predators while the other scans for prey. When it spots something tasty, both eyes lock on for perfect depth perception right before it shoots out its lightning-fast. These 2 prove that some animals didn't just evolve better eyes. They evolved entirely different ways of seeing reality. Some of the strangest eyes are underwater, where light is chaotic with heavy glare and shifting shadows. The cuttlefish has a pupil shaped like a perfect capital W. At first, it looks ridiculous, but it's an elite light shield. The top curves of the W block harsh direct sunlight pouring from the surface. The bottom parts let in softer light from the sides and below, protecting the retina from harsh, uneven underwater lighting. Here's the part that breaks brains. Cuttlefish have only one type of light receptor. They should be completely colorblind, seeing only gray shades. Yet they're camouflage masters, matching coral, rocks, and sand with perfect colors and patterns in seconds. We reach the absolute edge with the box jellyfish. No brain, no central nervous system, just a translucent floating jelly bell. Yet it has 24 fully functional eyes in 4 clusters called rhopalia. Each cluster contains 4 different types of eyes. 2 are simple pigment cup eye spots that only detect basic light and shadow. The other 2 are much more advanced, featuring a cornea, iris lens, and retina, making them look shockingly similar to human eyes. No brain means no unified picture. Each eye is hardwired for one automatic task. Lower lens eyes look down hunting prey and dodging mangrove roots or obstacles. Upper lens eyes have a heavy crystal weight at the base that keeps them always pointing straight up toward the sky, tracking the tree canopy above water for navigation. Regardless of swimming direction, it's not really seeing a scene. It's a living cloud of 24 independent visual sensors reacting instantly to light patterns from every angle. We humans look through round pupils and think we see objective reality. We don't. We're seeing only our version, built for our height and place on the food chain. Next time you lock eyes with an animal and feel that strange disconnect, remember, you're not looking at a different creature. You're staring into a completely different universe.